Hello, this is another EES education video, and what we're looking at here are just some of the basic functions. So what you see here is what EES looks like when it first starts up, and we have our equation window. And what we're going to be looking at here is if you go up under the options menu, second one down is function information, you'll get this menu that we see right here. And at the top are some radio buttons for different types of functions. They're grouped different ways. And so first you see we're looking at math and string functions. This is one we really won't use all that much, but if you kind of start looking down this list, you can see things like ABS, and that's absolute value. You can get down and get, for example, the arc cosine, arc tangents, things like that that you might be familiar with in math. If you see any listed, you're not sure what they are, you can click on this function information, and this will go ahead and describe what that function does for you. At the bottom, you also see how to use the function, and so here you realize that in order to use the arctan function, I would just use arctan and I would send it a single value. What I'm looking at, this is a fairly long list, as you can see here right now. On the right hand side are some groupings of it, so there's all functions. If you want to break it down into subsets, you can do that as well. Again, we won't really use this all that much, except for example maybe some of the trigonometric functions that you might want, for example sines and cosines. The one we look at primarily will be the second radio button down here, thermophysical properties, and this is kind of one of the biggest powers of EES. It has all the functions values that we have in the appendices of the textbook, and that's what's very useful. So if we kind of look, let's just kind of look on the right hand side here for a minute. These are all the different fluids that are actually stored within the program, and so if you see that one, first of all, this is a very, very long list. At the bottom down here we see is water. And so if you think in terms of the textbook, like half of the properties in the back are just for water. And so this actually contains it for all these different materials. So this is actually a very, very large data set that it has. The next thing, let's go back and look at the left, which are different functions. And these are all different various types of thermophysical functions. We're familiar with, for example, things like density. And now we're actually looking at things in like enthalpy in this class. So what we can do is, for example, let's look at the enthalpy function. The next thing down here, we see independent properties. And so the enthalpy is a function of two properties. We know that from the state postulate. And so what we can see here now is an example of how to use the enthalpy function. We just type the name of the function, then the material name, and then we give it two properties, and so they're temperature and pressure. We could go ahead and change that, for example. And so if I did this here, I could also specify specific volume and pressure, and that would give me the enthalpy. It's automatically filling in this example the material I have on the right. So for example, if I really wanted to know what that was for water, I would go ahead and type it in like that. So this gives you an example. If you just type paste, it'll actually stick it into your equation window for you. And so here we can go ahead and change a couple things. So we need to enter values here. So let's do the enthalpy of temperature at 100 and the pressure of 150. And then I'm going to hit the calculate button. This is this little calculator button right here. Its quick button is F2 as well. And what I realize is here's my solution. It gives me the enthalpy. It's 419. And my default units are kilojoules and mass. So that's going to be kilojoules per kilogram. Coming back over here, I can either type values directly into my function, or I can give it variable names. So I could say P1. Now I'd also need to define what P1 is. So then I could say P1 is equal to 150 and go ahead and solve it. End up the same value. Now it sees P1 as a variable, so it lists the solution to all of my variables that I have that I want right there. Let's go back and look again a little bit more at this function information. Let's look in the middle here, these radio buttons where it says real fluids and then ideal fluids. We're starting to look in here in chapter 3 the difference between real fluids and ideal fluids. And so for example, again looking at the enthalpy function, water, we said we need two independent variables, temperature and pressure. However, if I click on the ideal gas radio button, it gives me a different listing of materials. And by default, what EES does is it uses the chemical symbol instead of the name for it. And so I can actually come down here and look at water, which is H2O. What this is doing is it's doing water as an ideal gas, different behavior. And if I look at my example, now I realize enthalpy is just a function of temperature. And we'll see that here in chapter 3 of the textbook as well, and that enthalpy of ideal gases is only a function of temperature and you don't need pressure. So I could go ahead and paste that into my window as well. And then this is going to give me the enthalpy of water at entirely different conditions, which is going to be it as an ideal gas. So I can't set the variable of h to different values, so let's go ahead and call that h1. And you realize it gives you a different value. This is because it's at an entirely different reference point. So you wouldn't ever want to mix a EES file where you're using the words water, W-A-T-E-R, and then it as an ideal gas of H2O. You want to be consistent for your entire problem, determine whether it's behaving as an ideal gas or behaving as a real fluid. Let me also just mention a little bit, as you see, I'm not typing units in here, but there's some default units. And so if I look kind of at the bottom of this little window here, what you'll see is these are the unit settings that I have. It tells me that they're SI units, and so I have temperature, which is Celsius, pressure in kilopascals, and then energy in kilojoules, and then my mass, and then degrees, and that's degrees versus radians that it's talking about. I can change that. So if I go up under options and I come down to unit system, I can go ahead and change that. So I can go ahead and change it over to the English system, and now it's going to go ahead and use things like Fahrenheit and PSIA. So if I went ahead and change that, it's going to give me entirely different values because now my unit systems are entirely different. And again, I can look at the bottom of my window and realize that I have changed what my unit system is in there. So that's kind of something you want to make sure you've got it set properly. We mentioned there's a way if you want to kind of explicitly put it in here. There's this thing called a directive, which you start with a $ like that, and I can do, for example, unit system SI. And if I do that, when EES is run, it's going to actually go ahead and set that unit system to SI. So you realize I've now set it back to SI unit system by using that directive. I often do that because then it's really clear when you're just looking at the solution quickly in the equation window what the unit system is, and you don't have to go and click up underneath, for example, the options system as well. So, okay, well, that's kind of a quick review of different values of functions. The best way to kind of learn to use this is to just kind of go into EES and start playing around with different functions and looking at what different values you can get and how they change when you go ahead and use different fluids.